Okay, next section in this week is 3.2. So this section is about how to graph linear equations. So first we should know what is the linear equation. So we can list this one. It is linear equation. So any linear equation can be written in this form. So we only work on the linear equation in two variables. So here, x is one variable and y is the second variable, right? We have two variables, x and y. And here, a, b, c are all real numbers. A, b, c are all real numbers. Of course, x, y will be our variables. And we have another rule is a, b are not both 0. So if a is 0, then b cannot be 0 at the same time. If b is 0, then a must be not 0. So they cannot be the 0 at the same time. And we will say this ax plus by equals c is the standard form. This form called standard form of the linear equation. And by the name linear equation, we can know the graph of this linear equation should be a straight line. Should be a straight line. So that's why it's called a linear equation. We can check several equations to see if this one is linear or not linear. I just give you some. Let's see, we have this equation and this equation. Let's check all these three equations to see if it's linear or non-linear. Okay, let's check the first one. Can we write this one into the standard form, ax plus by? We already realized it cannot be right into the standard form because here, x term with the exponentials 2. So it's not x, it's x squared. So this is not the linear equation, right? Because here, x to the square, so it's not qualified. Let's check this one. This time, y is okay. by, that's fine. And we still work on this one. For this x term, this is square root of x. So if we write into the exponent form, it will be x to the half, right? X to the half. That's another way to write square root of x. So this is not x. So it's still not a linear equation. Then we check the last one. If this one is yes or no. X, that will be good. 3x. So for the x term is good. Let's check the y term. So this time we have 1 over y. Let's just think about the y term. The y term will be like this one. Y to the negative 1. 1 over y, if we write it into this form, that will be y to the negative 1. So it's not the y. So it's still not linear equation. So when you check an equation, make sure you know you should have x, y. Okay? So I will give you some examples for the linear equation. For example, we have this one. This is a linear equation, right? And even this one is a linear equation. And even this one, y is equal to 7. We do not have x, right? So we can treat it like this way. But this time, x so we can treat it like this. The coefficient a is equal to 0, but the b is equal to 1, right? And the c is equal to 7. So which means this is also a linear equation, but this time a is equal to 0. Remember, a and b are not both 0. So this time a is 0, but b is not 0. So this equation still qualified for the linear equation. Of course, for the first one, we can write it into the standard form like this one is already the standard form, sorry. And for the second one, I can write it into the standard form, right? If we both side minus 7y, we will get this. This is the standard form. So this one is the linear equation. For the last one, we know y is equal to 7. We can treat it the coefficient for x is equal to 0. So a is 0, but b is not 0. So this one is qualified. Of course, similarly, if we have this one, x is equal to 6. This one is still a linear equation, but this time we can write it into the standard form like x plus 0, y equals 6, right? So this time the value of a is equal to 1, but the value of b, the coefficient for y, is 0, which means b is 0, a is not 0. So this one is also the linear equation. So after we know what is the linear equations, we could talk about the objective here. The only objective here is try to graphing the linear equations. So basically, we will try to find the 3-ordered pair solution for a linear equation. Then we use these 3 pair solutions to draw the graph. So first, let's check this example. We have this equation. So is that a linear equation? 2x. So ax plus by equals c. So this is already the standard form. And we realize this one is the linear equation. If it's a linear equation, we can try to find 3-ordered pair solutions for it, right? So we can choose any number you want for x, then solve for y. Or you can choose any number you like for the y, then solve for x. So we can try it together. But we prefer to pick a number easy to calculate, right? So here, first, let's see, let the x be the 0. I will let x be 0. So first, let x be 0, then we use 0 to replace x, solve for y. Okay, so 2 times 0 plus y equals 5. Then we will get y is equal to 5. So the first paired solution will be paired. First pair will be 0, 5. So we will get the first point will be 0, 5. Okay, then we try to find another one. This time we let x to be 1, let's say. So we use 1 to replace x, then solve for y. So this time we will get y is equal to 3. Then we get the second point, 1, x equal to 1, y 3. So 1, 3 will be our second solution. Last time, maybe we will let the y. We can also set any value for y, then solve for x. That's your choice. This time, let y equal to 0. So then we go back to the equation. We solve for x. So 2x plus 0. This time, y is equal to 0. So use 0 to replace y. We will get x equal to 5 over 2. Oh, next. 2x equals 5. So we will get the third point will be but yet we already know we can use only 2 points to draw the graph. 2 points are already enough to draw a straight line, right? We already know 2 points already can draw the straight line. We only use the third point to test if it's correct or not. So first 2 points, we just use these 2 points to draw the line. Then we use the third point to help us check if it's correct or not. Then we try to draw the line. Of course, we can also list all the paired solution into a table if you want. X, y. So for first point, 0, 5, second, 1, 3, and 5 over 2, 0. So you can also list all the points into the table. Then we try to draw the graph. Let's say I would pick this one, 0, 5. 2, 3, 4, 5, 6. Then we try to -2, -3, -1, -2, -3. Okay, 1, 2, 5, 2, 3, 4, 5. Let's see the first one, 0. So here, x will be 0 and the y will be 5. So it's just on the y-axis. So this is the first line. Then second one, 1, 3. So 1 for x and 3 for y. We will locate it here. And 3 here. So these 2 lines is already enough, right? It's already enough to draw a line. So we can just try to connect this. To draw the line. Then we can use the last point to test if this point is also on the same line. Okay, so 5 over 2, it's just 2.5, right? It's just 2.5. So x is 2.5, it's right here. And y is equal to 0, so it's just the point on the x-axis. So it's also on the line. So we finish it. We use 2 paired solution to find the 2 points. Then we connect these 2 points to draw the line. And after that, we test if the third point is also on the line. So the last one is just for check. We can see another example. This time we try to graph this one. So we still do the same thing. We can set the value for x, then solve for y. We can also pick the value for y, then solve for x. So for example, we set the first point will be x equal to 0 because we pick the value, the convenient value to calculate, right? So x equal to 0, so 5, 0, 15. So this time we use 0 to replace x, then we only have the y term. Then solve for y, we will get y equal to 5. So the first point we will get 0, 5. Okay, so the second one, this time maybe let's check if y equal to 0. Let's set y equal to 0. Then we only have this. If we set y equal to 0, then we only have the negative 5x, the x part, right? And we know x is equal to negative 3. Negative 3. So the second point, negative 3 is 0. So we already know that's enough to draw a line, but we still test the third value. So this time maybe we try to use x equal to, let's see, x equal to 1 maybe. Or 2. Let's say x equal to 2. If x equal to 2, then we use 2 to replace x in the equation, then solve for y. We have negative 10 plus, so we will have 3y equals 25. Maybe this value is too big, so okay, we can change to another value. Okay, x equal to 1. Then we use 1 to replace x. 1 to replace x. So that will be negative 5 plus 3x equals 15. So that will be 3y equals 20. Y is equal to 20 over 3. So it's about 7. It should be very close to 7, right? Let's try to draw the graph. Of course, if you want, you can list all the values into the table. So the first point will be 0, 5, and negative 3, 0, and 1, 20 over 3. So let's use this table to help us draw the graph. First will be 1, 2, 3, 4, 5, 6. So let's check the first one. X is equal to 0. So x is equal to 0. So I put x here and y equal to 5. So the first dot will be this one. 0, 5, right? And the second one, x is negative 3. So put here, let's see, negative 3 and 0. So it's on the x-axis. So it's negative 3 and 0 for y. So it's on the x-axis. So 2 lines is enough to help us draw the line. So we can connect these 2 points to draw the straight line. But we need to test if the last point is still in the graph. So the last will be 1. The last point will be 120/3. It's just 6 and 2/3. So it's a point between 6 and 7, close to 7. So we use the last point to test, and we realize this point is also on the line, so we know we did the right thing. So we can also find the values, just like this one. We can try to graph this one. We can try to graph this one. Y is equal to -2. So first, we still need to find 3 paired solution, right? With 3 paired solutions. So, but this time, how can we find the solution? We can write this form into the standard form. We know this is a straight line, because we can write it into the standard form. This time we treated x, the coefficient for x is 0, so that's why we do not have x term, because the coefficient for x is 0. So if we want to write it into the standard form, so we can write it like this way: 0x plus y equals -2. So if we have this standard form, we can easily find the paired solution. So let's say if first time we set x is equal to 1, then we plug into the equation 0x, so it will be 0 times 1 plus y equals -2. So we have y equal to -2. So the first point will be 1, -2. Right? How about the second one? This time we set x equal to 2. And we have 0 times 2 plus y, -2. We will get the same thing, because 0 times 2, we also get 0. Y is still equal -2. So the second point will be 2, -2. And for example, this time we set a negative value for x. We use -1 to replace x in this equation, will be 0 times -1 plus y. And we realize still get a 0 for this term. We'll get y equal -2. And the third point will be -1, -2. After that, we list all the solutions in this table. It's y. So 1, -2. 2, -2, and -1, -2. We realize x can be any value. Y is always -2. So for this one, we will have x, y, 0, -1, -2. So we check the first value. Let's see, x equal to 1, y is -2, so it will be this one, right? x1, y -2. Second one, x2, y -2. This time -1, x is -1, but y is -2, so it will be like this way. Then we can connect all three. As we realize this is a straight line. And this straight line is parallel to the x-axis. So it's y equals negative 2. This is how we draw a graph only have x term or only have y term. So for example, this time we want to draw the graph like this way. X equal to 3. X is equal to 3. We want to graph this one. Similarly, this time we are missing the y term, but we know it's still a straight line because remember from the definition, we can write this one into the standard form. This time it will be x plus 0y equal to 3. So this time the coefficient for y is equal to 3, but the coefficient for x is 1, so they are not both 0. So it still satisfies the rule. It's still the straight line, but we can find 3 pair solutions. By this, let y to be 0, let's say. Then will be x plus 0 times 0 equals 3. So x equal to 3. So the first point will be 3 0, sorry. Second, let's set y is equal to 1. Then we will realize no matter what is the y value, we always get the same values for x. So this time we set y is equal to negative 1. So x plus 0 times negative 1. No matter what value for y, x is always get the same value. So 3, negative 1. Of course, we list the values in this table. We realize x can only be one value, 3, and y can be any value. Can be 1, can be negative 1, can be 0, but x is still 3. So if you already realize that, you will know x So for example, the first point will be 3 0, will be like this. And the second will be 3 1. And 3 negative 1 will be like this. So we realize we connect all of the 3 points, we will get a horizontal line. So x equal to a value will be a horizontal line. And from last example, we know y equal to a number will be like a horizontal line. This one will be a vertical line. So it will be a vertical line. X equal to 3 will be a vertical line. Y equal to a value will be horizontal line. So x equal to 3 is a vertical line parallel to the y-axis. And y equal to a value is a horizontal line parallel to the x-axis. So this section is all about how to graph the linear equation. So first, we know what is linear equation. Linear equation should follow the standard form. Okay, both a and b cannot be the 0 at the same time. Are not both 0. So if one of the coefficient be 0, another one should be not 0. So just like in this example, the coefficient of y is equal to 0, then we only have x term. If the coefficient of x is equal to 0, we only have y term. Okay,